Okay, so that just shows you how the test will be supposed to be. Um, this time you don't have to upload your answer, but next time when we're doing the test, then you have to. Okay, so tomorrow we will go to that 25 questions and try to explain to you. So basically, the test just given you very simple. Normally, interview you will be see it. Okay, so I don't asking you for too much calculation, just asking for understanding. Okay, so today we're going back for the JFET. Few things we need to emphasize. Then also we can go to bias, JFET, and JFET amplifier. And the last one will be MOSFET. Okay, so when you're looking into the symbol, you have to know this is a JFET, okay, and is it an N channel or P channel, okay? On this thing here, they just telling you, you get the current, the thing electron moving, okay? So basically, this is the channel, okay? Wider, more electron, more current, okay? That they just give it to you example for VGS in what the current ID, and that's for you guys to review it. We already did it, okay? And now on this thing here, you can see the current ID will be keep going, okay? Up to the point VDF, okay? Equal VP. That's what we call a ping off voltage. And the current now they will be constant. And that's what we call a IDSS. IDSS, that means the current with the VGS equal 0. That's the definition. Okay. And here more, explanation. Maximum drain current of the effect occur when the gate source voltage is 0. That means IDSS is the maximum current. The drain current is almost constant in the region between VP and VDS maximum. If the drain voltage too large, JFET breakdown. JFET act like current source when it is operating along almost horizontal path of the drain curve. That means between VP and the VDS maximum. Minimum voltage VP called a ping off voltage. The maximum voltage VDS max will be called a breakdown voltage. Between the ping off and the breakdown, JFET act like the current source with the value of the IDSS. IDSS stands for current from the drain to the source with the shorted gate. That means VGS equals 0. Okay, and we can get the ohmic region. The value of VGS that make the ID approximate 0 because V cutoff voltage VGS off. The JFET must be operated between VGS 0 and VGS off. Okay, VP is the value of VDS at which the rain current becomes constant, and it always measure at the VGS equals 0. VGS off and VP always equal in magnitude, but they both be opposite in the sign. Okay, a data set normally they given to you either VGS off or VP, but not both. You know one. You're supposed to know the other one. Okay, and now this will be display the VGS equal 0, -1, -2, -3, -4. So basically, the current ID here will be vary with the VGS. So that's why they say JFET is a voltage controller. Okay, that means you change the VGS, you change the current ID. Okay, so that's just showing you. Okay, now for the P channel, the arrow going out. Okay, P channel. The basic operation of the P channel is the same as an N channel, except P channel requires a negative VDD, okay, and a positive VGG, just opposite to the N channel. Okay, this is simple calculation here we already done. Okay, this is a transfer characteristic curve for the N channel. Okay, so basically ID equals 0 and VGS equals VGS off. Okay, VGS equals 0, ID equals ID at that. Okay, so this is the formula. Only the formula will be using to calculate the ID. ID equals IDSS times 1 minus VGS divided VGS off square. Okay, that's an example we already done. Okay, now the forward train conductance GM is the change in the drain current for a given change in the VGS. Okay, so basically GM equals delta ID divided to delta V GS. That's just a definition. Okay, and GM can be calculated by using the formula GM0 times 1 minus VGS over VGS off. Okay, the question is what is GM0? What is it? GM0 by definition, that means the train conductance at VGS equals 0. Normally the data set, they will be given to you GM0. If it's not, then you can using the formula GM0 equals 2 times IDSS divide absolute value of VGS off. That's only the two formula here. You need to calculate the GM0 or GM. Okay, so basically that's what we already done. Now, JFET bias, they can be gate bias or fixed bias, cell bias and voltage divider bias. Okay, we don't care about current source bias. Now, this is the fixed bias when you get a negative voltage applied to the gate in here. Okay, and basically, you know, this resistor here get a very high value. So the current cannot go through this resistor. That's just telling you the voltage at the gate and the voltage VGG will be the same. Okay? And the question is, how do we need this thing, RG? You can connect directly into the gate. Then the gate voltage and the VGG will be the same. However, this one they just explained to you. When they doing amplifier, you get a sine wave applied to the input here. Capacitor here will be by AC coupling. So you get a sine wave in here. However, when you're converting this circuitry into AC, the power supplied by VGG must be short to the ground. Okay? If you don't have a this resistor here, then the sine wave cannot go to the gate. They will be short to the ground. So that's why they have to get RG. Okay? Even they're not doing anything for the buyer, but they will need it for the AC. Now we're talking about cell buyer. I expect when you're looking into the circuitry, you have to know is it a fixed bias or cell bias. Cell bias, they don't have any power here. No power. Okay? That means without the power to the gate, the Jefetmosfet still working. So that's why they call it Jefetmosfet is uh, on device. On device means even they don't need the voltage at here, they still working. Bipolar transistor will be off device. The thing is bipolar, if you don't have a voltage at the base, transistor not working. Okay, they need the power, so they will be off device. Okay, and if you get the cell bias here, okay, so if you want to do it, you want to calculate the ID, you very tough, very difficult to calculate it. So that's why they want to use in the graphic. They go given to you for this trend conductance here, okay, in order to help you to find the ID, okay, and also the same thing. This is the voltage divider bias, okay, and also for this divider bias, you have to get the graphic in order to solving how to calculate the current ID or VGS. Okay, and now we go. This one we already done. That's the example for the cell buyer, and make sure you go through it. You're able to calculate the VGS. Okay, you can see the answer here. VGS equal VG minus VF, and VG equal minus 2 volt. VF equal 0. So that's why VGF equal minus 2 volt.
Mr. Pham, can that circuit be simulated?
Yeah, you can simulate it.
Thank you.
You want to show the simulation?
No, I was asking if that circuit that you're
That's
showing,
That's easy.
but PSpice can simulate.
Yeah.
All right, thank you.
The guy will be get the homework. Okay. So after you get the VGF, You want to calculate the VID. You have to substitute into the formula. IDSS times 1 minus VGS divided VGS of square. Okay? And after that, everything will be easy. VS equals 0, VD equals VDD minus ID times RD. Okay? Now, I want to try to explain to you today for that graphic. Okay? So now, first thing is they given to you the train conductor here. Okay? So in order to in order to get the Q point, that means any point on the curve, then you need to get 2 points to draw the load line. Okay? So we'll be helping you how to get that 2 points. So if you're looking into the formula here, VGS equals VG minus VS, and VG equals 0. So that's why they will be equal minus ID times RS. Okay? So from this equation here, they say I need 2 points A and B to draw the load line. How to do? For the point A, first thing I set ID equals 0. If ID equals 0, I substitute into this equation here. So VGS equals 0. So that's why you get point A right here. Okay, that's 1 point. And now you need the second point. You can get any value of the ID, any value greater than 0, equal 10 or less than here. Okay, any value you want. You can say, okay, I want 1, 2, 3, ID equal 3, that's okay. However, in here, point B, okay, set ID any value greater than 0 and let equal ID at that. However, in here I pick ID equal ID at that. That means I pick ID equal here. Okay, with the ID equal 10 milliamp, I substitute into this equation here. I doing calculation, I get VGS equal minus 4.7. So this is the minus 4.7 right here. This is the 10 milliamp. I draw the line here. Okay. And I draw the line from minus 4.7 up to here. They get the point B. That is how I get point A and point B. Then from A to B, I draw the load line here. Okay, intercept right here, that's a Q point. You want ID, you go to the right. That will be ID. You go VGS, you want VGS, you going down. That's telling you the VGS. Okay, so if you're looking into the calculation, okay, then ID Q equal 4.8 milliamp. Okay, VGSQ equal minus 2.5. That means in here minus 2.5 and right at this point will be 4.8 milliamp. Then you can calculate the VD. Okay, that means VDD minus ID times RD. And VDS equal VD minus Vs. Okay, even you don't have to do it. Okay, however, try understand that really good for you. If you go to the college, you go to university, then you have to do. Okay,
Hey, Mr. Pham,
yes, sir.
um, on your instructions there in the red where it says select ID equal 10 milliamp, then VGS equal 10 times 0.470. Where's the 0.470 come from? Oh, I mean, that's the resistor.
Yeah, time RS. Okay.
Okay.
However, you're using milliamp, then RS will be 10 to kilo ohm.
Oh, okay. Yeah.
You don't have to converting.
Yeah. I got you now.
Okay.
Okay. I missed that. Yeah.
Yeah,
That makes sense. Thank you.
you're welcome. Any question, anything? Really, this time we be online. That's a very good for you guys to get your knowledge. Okay. So any question on this thing? No? Go to next one. This is they try to explain to you. Okay. For a voltage divider with the graphic. Okay. So if you're reading here, you can see at this point right here will be VB, VG, okay, VS, VD, okay. So first thing they need to calculate the voltage at the gate, then using voltage divider, okay. That means 12 volt times 2.2 divide 2.2 plus 3.3. So that, okay, given you the value will be 4.8 volt. Okay. And then you can calculate the VGS by definition. VGS equals VG minus VS. And VG equals 4.8. And VS will be ID times 3.3K. That means RS. Okay. So this is the equation will helping you to get 2 points to draw the load line. Okay. Calculate 2 point AB to draw the load line. First thing, we get point A. You set ID equal 0. ID equal 0, that means this will be equal 0. VGS will be equal 4.8. That's the first point. The second point, you set the VGS equal 0. Then that will be telling you 4.8 volt minus ID times 3.3K equals 0. Okay, and you will be solving, okay, for ID. You already know IS 3.3K, 4.8 volt already. ID will be equal 4.8 divide 3.3K. You get 1.45 milliamp. Okay, so basically you already get 2 points. First point is you get the VGS equal 4.8 volt. The second point you get ID equal 1.45 milliamp. Now you can see how can we draw that. First thing you get point A here. VGS equal 4.8 volt. Okay, this is a 4 volt, 4.8 volt, 1 point. The second point, you get the ID equal 0.45 right here. Okay, point B. You draw the load line from A to B. They intersect right here. That's what the Q point. Okay, go to the right, you get the value for ID. Going down, you get the value for VGS. After you get the value for ID and VGS, then the rest will be easy. Like, you calculate the VS, or you calculate the VD, or you calculate the VDS. That's a very basic, okay? So any question?
Mr. Pham, that previous slide, number 1, we were converting from meg to kilo.
Yeah. If you get which one?
Line number 1 calculation. Go up. Go back up. Go back. Go, yeah, keep going. One more. Next one. Line 1, we're doing a conversion there, right? From meg to K at line 1, 2.2 K or 2.2 meg. That's a conversion, right?
2.2 mega ohm. The thing is R1 mega ohm, R2 mega ohm, don't worry. You basically, you take 12 times 2.2 mega ohm divide 2.2 plus 3.3 mil. Same unit. You don't have to convert anything.
All right, so 2.2 K and that mathematical formula doesn't have to be meg. All right, thank you.
You can get 2.2 K to 3.3 K. That's okay. Okay? The value still be the same. The key point I want to bring it up to make sure you know how to get 2 point A and B. Okay? But normally, when they given you the voltage divider bias, or they given you the cell bias, they don't want to use in the graphic. So that's why they must be given to you either they given to you the VS or they given you the current ID. Okay? So that's why you don't have to use in the graphic. Most of the textbook, they will be doing that way. Okay, any question on that? Okay, for this problem here, you think can you do it? If you have to doing this problem, my question is, can you guys do it? That means you have to draw the load line.
Okay, Mr. Pham, if I could just start it out, maybe people can jump in. So the first thing you would have to do is you would have to pick a point on the line. Is that correct?
Now you have to get the equation first, right? You understand that you know VGS. VG
Minus VS.
VS. And VS equal ID times RS. So that will be given to you VGS. VG is 0 minus ID times RS. Finally, the equation will be Okay. So based on this equation, you're looking for 2 point A and B. You must follow the rules, okay? A, that means you set ID 0. You're looking for VGS, right?
Mhm.
ID 0, VGS 0. That means the first one right here. That one A. Okay. Then you need a second point. You say point B. They telling you point B, you can select ID from here down here. That means any value you want. They don't.
Okay, Mr. Pham, select one in the middle.
Yeah, you can get it in the middle. That means 10. So 1, 2, 3, 4, 5 right here, right?
Right.
So I say I want ID equal 5 milliamp. Okay, then VGS equal minus ID time RS equal minus 5, right? You want 5.
Right.
RS is 0.47. And that will be telling you VGS, okay, 5 times 0.47, 2.35 minus volt. Okay, so now this is the 1, 5. That's what you pick. You draw the line here, right? Then now you're looking for VGS equal minus 2.35. 1, 2, maybe here. Minus 2.35. And now you can draw the line. Okay, up here. This is the B. Then you connect A to B. Okay, when they intersect right here, that's the Q point at this point.
Only where the line crosses the blue line. So how do you make the blue line?
They give it.
That's the specs from the manufacturer, correct?
Right. That is a given uh, conductor. You cannot doing anything with that.
So
Only thing is you need to draw the load line, intersect with the blue line in here. That will be the Q point.
so VGS and ID will never touch that blue line, correct? Sometimes maybe. And our only Q point is when we draw the straight line. So when the
Yeah, you must draw the straight line.
right. So even though we have the answer 2.3 and 5 million, That's not the exact Q point. It's only where the line crosses
Exactly.
blue line. Right. Right. Got it.
The thing is, sometimes, I can fix ID equal 10. That means here. Then I substitute into this equation here. I calculate, they're telling you minus 10 times 0.47. That will be telling you minus 4.7. So 1, 2, 3, 4, 5. Okay. Okay. 4.7 is close here. So you draw the line here going up here. Okay. And you draw Z going up, Z the point B right here. Okay. Then A here, B here, you can draw the line. Okay. Any question?
Does
Yes,
that
yep.
mean it's working out of the range of the current specs?
No, it's not out of the range.
All right. So if we're working with the blue line as our Q point value,
Right.
how does that B point indicate a Q point value if there's no blue line?
Now you must get the blue line. If you don't have it, that means you cannot solve the problem.
Right. So your example was hypothetical. It wasn't exact to the current formula.
Now,
Mr. Pham, before you erase that out, I had a question.
yeah,
On your very first one where you had B, you said B is ID is equal to 5 milliamps, and what's after that?
right here.
Then
Oh,
that,
then.
yeah,
Oh, THEN.
that was
Okay,
part of
all
my
right, I got it.
That's what equation you need.
Mhm.
When you try to get the value of the ID, substitute into that.
Mr. Pham, because on your example, you've been using for the ID, you've been using basically, which is IDSS, which is the max,
Right.
because you've been using 10. And that's why I had you use the one in the middle, which is 5, because I wanted to see what it was like when you didn't use the absolute max.
Yeah, the same thing.
Right, right, right. Okay, thank you. Thank you.
Yeah, just pick a simple one so we can easy to doing a calculation. Now you can see the same problem. Okay, but that is just for your guy to read it, to follow it. I try to explanation right here. Okay. Okay, that grid down graphic. Try to explain to you again. This is a sale buyer. Okay, down right here. So normally you need the graphic. However, if they're not using the graphic, they must be given to you, either ID or VS. In this case, they given to you ID equal 1 milliamp. So you already get the ID, okay? And basically they want VG equal 0 for sure, okay? VS equal ID times RS, or VGS equal VG minus VS, okay? And VD and VDS, everything will be easy to do in calculation, okay? So normally, when you get the test, that's what I gave it to you. I'm not giving you a graphic. We cannot do it in online, okay? Normally, you have to do by hand. However, if I gave it to you ID equal 1 milliamp, and you're able to telling me what VS equal, what VGS equal, what VD equal, or what VDS equal, okay? Any question? Okay, if it's not, that's just a voltage divider. So you can try, okay? If you want it, same thing. You have to calculate the VG, okay? Then you can calculate the VGS, okay? I try repeat again one more time. You understand a VGS, VG minus VS. In this formula, VG you already know, okay? 15 times 100K divide 100K plus 390K. So already know. Okay. And now let's see. I try to see they can do calculation here. Okay. VG 3.06. Okay. So VGS 3.06 minus VS. And they will be equal 3.06. VS will be ID times RS. That will be VGS. This is the equation you need to get 2 points. So first thing they say, they set ID equal 0. Point A, ID equal 0. So 0 here, they're telling you VGS equal 3.06. So that means right here, okay, they can write the 3.06, okay? That means they have to draw up to this way, 3.06. That's point A. Then now you want to calculate the second point B. Then you set the VGS equal 0. 3.06 times ID RS minus, sorry, minus ID times RS. Okay, so that will be telling you ID times RS equal 3.06, and you need to calculate the ID. 3.06 by RS. Let's see, they already calculate here. Okay, 3.8. That means you get 3.8. milliamp. So that is a 10. 1, 2, 3, right here. 3.8. That's the point B. Then you draw A and B. Okay? They cut right here. That is Q.
Hey, Mr. Pham, so basically your point A is you have the y-axis and that the original y-axis where you got the 3.06 or the 3.0 is to the right of that, correct?
Right. The thing is at the 0 here. Right here.
Yeah, that's 0.
Negative.
Right.
Line positive.
Okay, because your ID was no, what is that, VGS or something?
Right? That VGS.
Yeah, that's positive, correct?
Right.
So that's why it's to the right of 0.
Right.
Okay, yeah.
So basically they given that I given you a graphic in here. Later on, we need also in the positive. You can say that what they given to you. So normally you don't have to do any equation. You still can draw. The thing is they say first point. This is the first point. A equal VG. If you calculate the VG by voltage divider, that means you get that point. And the second point right here, B, they equal VG divided IN. So that's
And
why
that's
you don't have to
ID.
come up with any equation. You can draw easy.
Yeah, and that's ID right there.
Right, B at the B. That means you take a VG divided to IN. Whatever you get, that will be ID. That's the second point. And you draw the line from A to B. You get the Q point here. Make it so simple. Okay? So only for this circuitry, you only need to get the VG. That means you need to get right here. Okay? That given to you a point A, VG. Then you take a VG divide to IF here. That will be given to you the value of the ID right here. Second point B. You draw the line. That's it. Don't have to go detail like I show up to you. Okay, that's what you need to do now. Okay, in this case, we don't have a graphic. Now, if you don't have a graphic, they must give it to you, ID or VD. In this example, they gave it to you VD equal 7 volt. So you don't need the graphic. If I want to calculate the ID, how do I do? That's what when you're testing, I will be asking you.
You mean like 12?
calculate
You mean-
ID.
Hey, Mr. Pham, do you mean like 12 volts minus 7 volts and you get 5, and then you could do the
12 minus
RD?
5,
Yeah, right,
3.3K.
right, exactly.
That's what you get ID.
And then once you get ID, you can do you can get VS.
Right. VS equal ID times IS. Right?
Right,
Now, VG, you have to using the voltage divider. Right?
right.
VG equal 12.
12 times 6.8 all over 6.8 plus 1 meg.
Exactly. 12 times 1 meg.
No, 12 times 6.8, right?
No, one May. R2 time R2.
How much you?
Oh, R2, I'm sorry, yeah.
By R1 plus R2.
And then you add them both in the bottom.
Okay. So you can get 6.8K plus mega here have to change into K. Okay. They have to be the same unit. So you get a 1 mega ohm. You change to the K. They will be equal 1,000, right?
Mm-hmm.
1,000 K, right?
Right.
That will be also 1,000 K. So that's what you can get the VG. Okay. If you want VGS, VG minus VS. If you want a VDS, VD. So up to this point, you guys get any question? You really want to be a technician, then must be trying to understand. Okay. Electronics is not lucky. You must be understanding. Okay. Let's see. That's done for this guy. Okay, let's see. Another one will be Jefetmosfet biotech. Okay. On this one, we'll be talking about again for Jefet amplifier. In here, they say Jefet commonly used to amplify small AC signal. One reason for using a Jefet instead of a bipolar transistor is that very high input impedance Gin, okay, can be obtained. A big disadvantage, however, is that the voltage gain AV obtainable with the JFET is much smaller. Okay, so to you guys, when you're looking into the amplified JFET circuitry, first thing you need to recognize is it a common source, a common gate, or common drain. That is the first thing. Okay, must be. Now in here also for any either bipolar or the JFET or MOSFET, same thing. you want to converting DC to the AC circuitry, you must be follow the following 4 steps here. First thing, you have to set all the DC source to 0 and replace them by short circuit equivalent. That means if you get any voltage source, short it to the ground. Second thing, replace all the capacitor by short circuit. So that's why when you're looking into the AC circuitry, you didn't see any more capacitor. They just lay the wire. Number 3, remove all elements bypass by the short circuit equivalent as introduced by step 1 and step 2. That means bypass capacitor also you don't have it. They just lay the wire and redraw the network. Okay. So this will be a common source amplifier. Input will be applied into the gate. Okay. And now that will be explained to you why we need this resistor. Okay. If you don't have a resistor, they will be connected to the ground. You cannot get sideways here. Okay, so when you're looking into this common source amplifier, what the bias will be using? Again, you can using the fixed bias, or you can using cell bias or voltage divider bias to build the amplifier. Okay, so even you cannot do memorize all of the formula to doing a calculation. However, you must know what the bias they using. In this case, they're using cell bias. Okay, so in general, common source input signal applied to the gate, and output signal will be coming out from the drain. Only thing is, input, output will be our phase. That's what you must know. Okay? And what the capacitor here? What the capacitor here for? What the name?
Bypass.
Of the
Bypass. Bypass.
bypass. Okay? This is a bypass capacitor. And they can ask you bypass what here? What they want to bypass?
They want to bypass that resistor.
Exactly. They want to bypass 200 ohm right here. Okay? That means the AC current, when they go up to this point,
It goes to ground.
they go to ground bypass. Okay? So on this point right here, Vs do get a voltage 1 volt for DC. Okay? However, if you measure the AC, you're supposed to get 0. Okay? I think it is short to the ground. And also on the drive, the drain right here. At this point, you get also 2 different voltage. One will be DC voltage for the bias. Also, you can get the sideways, okay, signal. However, when they go into the load right here, they don't have any DC voltage. The thing is, this capacitor will be,
AC coupling.
okay, blocking DC,
Blocking DC.
AC coupling, okay? That is basically You don't have to do any calculation, but the minimum thing they want you, to see how much you understand it. Okay. Then if I'm looking on the circuitry, I know, okay, this is a common source amplifier using the switch bias circuitry, okay, to build. And also, I know this capacitor here is a bypass capacitor. That means they bypass the current AC go to this resistor RS 200 ohm. Okay, and also at the drain in here, you get DC voltage and the AC voltage. However, when they go to the output to the load, this capacitor here be blocking on of the DC voltage, and you get only sideways coming out. Okay, so now if you're using your oscilloscope, you measure at this point. You want to measure this sideways here. What your scope will be set up for coupling. Which coupling you want?
AC.
Coupling or AC coupling. If you want to measure at this drain right here, and you must be set it up your oscilloscope. In set up your oscilloscope, you can get DC coupling and AC coupling. Which one you want?
Right there is AC.
You must set to AC coupling. Okay? The thing is, the voltage DC here will be big. The signal sideways here will be very small. If you set it DC coupling, on your scope, they will be displayed both DC and AC. And when you get the too big DC set, voltage, you cannot see the AC voltage. So that's why you must be set AC coupling. Okay?
Hey, Mr. Pham, at that point, that's where the load resistor and the RD will be in parallel, and that'll give you the little RL.
Yeah, that's what you're talking about when you go into AC.
You make the VDD 0 and then short out that coupling capacitor.
Right. That means, let's see, I try to see how they draw that one. Okay? This is the one they draw AC right here. This is the input V in, and also that will be RG. Okay? On the other side, they just normally from the drain go to the source. You get the current will be value GM time VGS. And also for the load in output load in here, output impedance, then you can get a 1 RD and RL in parallel. Okay. Now, when you're looking on this one to see how much you understand, you get the gate right here. Okay, this is the source right here. Okay, so from gate to the source, you get the voltage will be VGS, VGS. Okay, and from the drain, you can get the current going from drain to the source, and the value will be GM time VGS. Also, inside the Jefetmosfet, between the drain and the source, you get the resistance R small d inside. That the resistor will be very big. So that's why normally they ignore that one. So when you're looking for the AC, they want to know what is the input impedance. That means you're looking here. You go see into the amplifier. You see that is the resistor you get RG, that's input impedance. And now, if you're looking from the output here to the amplifier, that's what they call output impedance. And in this case, they say GL equal RD. They get GL equal RD. That means the circuitry have a no load resistor. If you get a load resistor, then you have to be get a GL equal RD parallel with RL. And this is the formula to calculate the gain. You take V out divide to V in. They get a minus sign telling you input output will be our phase. And GM time RD. RD means output load. In this formula show up here, you have a no load. Let's see. This you get a load here. Okay. However, this one without the load. Okay. So that's why they time RD. If they get a load, then this have to be RD parallel with other load. Okay. So that is same thing. Phase relationship. Okay. Common source amplifier configuration had 180 degree phase shift between input and the output. Okay. And this just an example for common source. Okay. For this common source in here, they using fixed bias. Okay. They using fixed bias to build it. Okay. So we will be continue it in tomorrow. Okay. If you get the time, you already download it, you can read it. Common drain and common gate quickly. Okay. Then we can go into metal oxide semiconductor MOSFET. Okay. Try to finish it tomorrow. And also tomorrow, I will be showing you the test we already did today. Okay, up to this point, any question? Make sure next week will be no class. Okay, that's a Thanksgiving. We take a whole week off.
Oh, man.
Yeah,
So Thursday is the last day this week until next week, right? I mean, week after next.
yeah. The thing is next week, Thanksgiving. I believe we return on November 30th. That means last day for November. Then we get another 3 weeks on December, then we take a half month for Christmas. Maybe this year we can take a little longer, depending whatever they want it. Then after the Christmas, you can get about 3 more weeks, then we be end for the fall. Hopefully we get a chance to return to the lab. That's much better.
Mr. Pham, you're extremely optimistic, but based on what I've been hearing, I don't think that's going to happen.
I don't know.
Glass half full, Smith.
We're gonna have a potluck. What are you talking
Oh,
about?
yeah, that's right. The glass is, you got to think that the glass is half full, right?
The thing is right now, nobody coming to the office. We cannot do anything. Only thing I try the best. I try to helping you to understand, okay, in order when we able to get back into the lab, then you take a short time, you will be complete.
As far as the office go, Mr. Pham, maybe you ought to get up early in the morning. Maybe they trying to duck you or something.
They must return to the lab. That's what I think. That's not for this school, for everywhere.
Yeah.
They get something will be happen. Don't worry about that. Okay?
Yes. Yeah, we just got to hope for the best. That's all.
Right. We don't want it, but what can we do?
Yeah, that's true.
Okay, so we will see you guys tomorrow.
Okay, Mr. Pham, thank you very much.
You're welcome.
Thank you.
You're welcome.
Thank you, sir.